We will be demonstrating, using a balloon, how this feat is possible because of pressure. To conduct this experiment, you will need a hammer, a drill with a bit the same size as your nails. You will need a box of nails, obviously, a thick wooden board with evenly spaced holes, we used 1 centimeter apart, and also a few balloons. We'll now show you how to set up your experiment and drill your holes for the nails. So first we're drilling holes into the board along a grid that we made so that each of the holes are going to be 1 centimeter apart from each other. Make sure you have adult supervision and prior instruction before using a drill. We are drilling the holes in the board so that the nails will more easily slide through the wood when they're hammered in. Now we're going to be hammering in the nails.
Just take the nail, like so, and just tap it in.
Be careful of all hands and feet.
Do not put your fingers near the head of the nail. Okay, let's check our progress. It should look a little something like this.
Yes.
Pointy side up.
We changed our setup so that we could be working on a more flat and stable surface, and we found that this was much easier to hammer in the nails.
Father-daughter goals.
Alright.
This was our last nail. After we finished hammering it in, we straightened out some of the nails on the bottom. After off-camera trial and error, we concluded that the nails had to be more densely packed in the board so that a greater force was required to pop the balloon. In the beginning, we also set aside a board of wood with only 1 nail hammered into it for the demonstration. So here's what happens when you have a balloon and a single nail. You can probably guess. We use a box on top so that even pressure is applied to the balloon.
I'm just scared.
Look at this.
It works! Oh my god, it works! That's cool.
Nice. So you can see, it's not popping.
Pressure is the application of a certain force over an area. This is the equation for pressure. Pressure and area are inversely proportional, so the greater the area that the force is applied to, the smaller the pressure. The bed of nails provided a much larger surface area for the force to be exerted over, which was us pushing down on the balloon. The balloon pops with 1 nail because the force applied is concentrated in a small area, so the pressure is high enough to pop the balloon. When the balloon is on the bed of nails, its weight and force applied is distributed over a larger area, so the pressure on each nail is decreased. More force is now needed to pop the balloon. So with more force comes more pressure, and with more area comes less pressure. And fun fact, this is why a person wearing high-heeled shoes exerts more pressure on the ground than does an elephant. These are not our calculations, but they offer another mathematical and conceptual understanding of pressure. There is no exact way to measure the force that we are pushing on the balloon with, but the force acting upon the balloon is shown by the amount that it deforms. Here's an example. If we applied 10 newtons of pressure to the balloon over the area of the bed of nails, which could be about 0.2 meters squared, we would get a pressure of 50 newtons per meter squared. However, if we applied that same 10 newtons of pressure over a single nail with a surface area of 0.0002 meters squared, we would get a pressure of 5,000 newtons per meter squared. When the force is applied to the balloon on a single nail opposed to a bed of 100 nails with a much larger surface area, the pressure is significantly greater and causes the balloon to pop immediately.